will be teaching you introduction to Java programming from the deeper perspective, from the very basics, and let's get started. So, what's programming? Programming is a creative process done by programmers to instruct a computer on how to do a task. So, what type of creative process is programming? That is a question. It's something, it's writing instructions in some order with the right syntax. So, you write instructions in you cannot make any grammatical mistakes like you make in your language, typical language. Here you have to write programs into certain syntax, and if that syntax doesn't match that programming language, then the code will not run. So it's like writing a recipe, it's like cooking food the way in the right way. You have the right ingredients, you have to make the food in the right manner in the right time, and it will cook and it will be tasty. So if you're not cooking the right manner, the program will be very bulky, it will be very slow and won't be that good. So now just like explore what programming really is. So now in the ideal way, it's like coding in real life. So I say like, see if you can see this diagram. I have a friend. His name is Mike, and he is at railway station. He has arrived at railway station. That's my home, and he wants to reach my home. So I because I live in that town for long period. So I ask him. Okay, I say okay, I know a way. He asks me. Okay, he calls me. He says okay, I want to come to your home show, but I'm at the railway station. So how can I come to your home? So because I am living resident of the town, I say okay, I will instruct you, and you have to just follow that way. So I instruct him path A. So it's a little complicated, but it's the shortest of the two. Like we are considering A and B here. Have sharp, confusing turns. So because I know this way, I know it's a shorter one. So I instruct him for this way. So I say okay, from the railway station you have to go downwards, then for say around 100 meters, then you have to turn left, you have to move 50 meters, then you have turned right, you after, and then you will go here for 200 meters, you will find a coffee shop. From there you have to turn here, and means I will just instruct him, and maybe like if he misinterprets me, or if I say like here I say if turn right instead of turn left, then he's completely lost. So this is one part of like coding in real life. So I'm coding him, but I'm not coding in the right way, I'm just making him confused. And this is the bad in coding also. It's something a bad practice, like you're making programs and they run, but it's like they are not running the right manner. The code is very complicated, everything is very complicated. So the program will be good, it will run, but it will won't be that good, means the results won't be that nice. Then okay, Mike says okay, I'm just getting confused. Okay, can you tell me a very simple way? I don't care whether it is long or short, but I want a simple way. So I instruct him. Okay, you can I tell him another path, like he's in the railway station, I tell him another path. It's a little longer, it's a highway. So from here it's you have to travel straight way in a highway. There are four traffic lights. Okay, one, two, three, four, and you can reach home. This is a simpler way, and you have to just take a small turn so he can reach my home. So this is like this, he reaches here, and to my home. So here he says it's easier for him. It happens in programming. Like we know how to run the code, but we are not using any special methods, any design methods, any algorithms, anything. So this code is very long. It's the longest in these three codes, like ABC. It's the longest one. It's very simple, but it's very long, and there are many hiccups. Like traffic lights are there, so he will reach home. It will take time, but he will reach home. So that is the second part. So a bit longer path with normal turns and easy path, reading but not efficient. Now is the third part. New technologies have come in the market. You are a programmer, and there are many new techniques that have come. So okay, last time Mike came to my place and he had to follow path A or path B. Now after some years he has arrived again, and now there's a metro station between my home and railway station. Now what he have to do, he comes to railway station, he says okay, I've arrived, please guide me the way again. And I say Hey Mike, it's very means you're very lucky that a new metro path has been opened. I mean, you can just travel straight to my home from railway station. So it's just you have to take a ticket from here, and the metro you can reach my home, and it's very cheaper too, and it's very fast. It's quick. See, it's very quick. So see the shortest path possible between the two places, the most efficient and also the simplest. In software terms, in software words, we call it like we implement frameworks, like we have the Spring framework in Java, then we have design patterns, we have algorithm designs, we have memory savings, then we have IDEs, there are different IDEs, Eclipse is there, NetBeans is there in Java. So there are many things like that are implemented to make the code better, to make the code faster, to make the code run in a more controlled way. So this is the part C that like most experienced programmers, when they learn programming, when they learn the path A and B, then they follow the path C. So before I move forward, let's revise these. What is programming? So the first definition was programming is a creative process done by programmers to instruct a computer on how to do a task. So the creative process in the next diagram are the paths A, B, and C. The C is the most creative one. It's the shortest one. It requires some experience, but it's like the it will give the maximum productivity. And paths A and B, path B is the simplest one. You're writing code. It's like you are following the normal coding techniques, and the code is large and it's not that effective, it's slow. So that's path B. And path A is like when you're making code, you're not commenting code. It's like you are not describing the variables in a proper way, and that is the very confusing thing in programming. So that is what programming is all about. It's following your creative process in a more defined way. So path C in this diagram is the more better way to do coding. Now we just come to the types of programming languages. So we have this is the hierarchy of programming languages. We have machine level language, a low level language, and the high level languages. Now the machine level languages, each CPU has its own instruction set. So for each instruction set, we have a machine language. So this is the low level machine language. It's basically a binary machine language, and it's very confusing. So that was like when the first type of computers were made, they used to follow machine language. So it was very tedious, it was very slow. Then came the assembly language. It was little human readable. It was a low level language. So then was assembly language. These languages are platform dependent, like they depend on the PC you're programming, they depend on the machine. So the code that is made for one machine or one type of platform will not run on another machine in case of low level languages. And then comes the high level languages, where the code is if it's made for in one platform, it will run on another platform. There's a technique I will talk to about this in the next diagram, how it is possible. So this is possible in high level languages, and you will see that this is the hardest language to learn. Then it becomes easy here, then more easier here, more easier here, more easier here, more easier here, and easiest at this level. Like we have HTML, CSS that runs in every browser. Even JavaScript and jQuery runs in every browser. So that is like it becomes simpler and simpler when we go to the higher level. But at lower level, we are more dependent on the machine. We can control the machine aspects. We can control the hardware. We can control the registers, the CPU, everything. So most of the operating systems, even nowadays, are made in C or C++. The gaming industry, it works in C++ because in games memory is required, everything is required, and it's a real-time process. It's a very fast way. Thousands of elements are being controlled, so they use C++, not Java, in the gaming world or in programming and operating system. So next we come to like difference between C and Java. So basically this course is about Java programming, so should know the difference. Like in C, you have a source code. You make some source code in C, then there's a compiler. You have to run the compiler, and it gets into something machine code or .o file in C. So that machine code is run on the CPU. Now the CPU is like like if I have Intel x86 processor, so for that you need this compilers. For other processor, you will need another compiler, and this code won't run on other platform. It's only when this is converted to this machine language, it only runs on this particular CPU. Now Java changes this thing, like we have a source code in Java, then we have a compiler, it changes to something called a bytecode. Now this bytecode can be run on any CPU, any platform. Each CPU will have a different JVM. This is called Java Virtual Machine. So what it does, it acts like a compiler also. It converts the bytecode into machine code. So like if I have Android, if I have Linux, if I have Windows, and like computers have x86 architecture, servers have X means Itanium processor, and Solaris have different processors, and Android have different processor. So there is a JVM for each and every type of CPU that is in those devices. And what I have to do is I write Java code, so it's write once, run anywhere. So with my local compiler on my IDE, I can convert this to bytecode, and this bytecode will run on any machine. For a different CPU, there will be a different Java virtual machine, and so I just have to convert my code into bytecode, and this will run on Linux, this will run on Windows, this will run on Android or something. Means there are some APIs, the mobile version of Java, it doesn't support many APIs that desktop version supports. So it's like if that JVM supports those APIs, that's application development libraries. So it will convert that code into machine code, and it will run on that particular CPU. So now next we just see a simple Java programs. In it's in the starting, so I just made a simple Java program. So in Java we have packages, like each software, each project has a package. So it's a basic package. You have a basic package, then you can make your own package. So it's you can in this it's com.showbit.basic. So this is like you can make your own package, so it's named like this. Then you have public simple class, I call it simple class. Then we have a main function here, public static void main. I will explain this statement after some time. And then we have system.out.println hello from simple class. So what it will do, it's like it will convert this whole thing into bytecode. And if I have means I can run this bytecode on any computer, any thing available, because the simple code, it will even run on mobile devices. It will, the JVM will convert that into machine code, and that can run even on mobile or something, because this is a simple code. Like if we have advanced APIs that are not supported in mobile, then that code won't run. So this is something about the basics of Java that you should know before we move on to the higher level. Thanks for watching.